You with me here?
Yeah.
But what's crazy is that oxygen, it's like, without oxygen, there's no way to manufacture air or water or power. Wow. So without all this stuff, like, we wouldn't be able to survive, period. Right? It's crazy. What's cool about this is that we were talking about this whole situation with Apollo 13 and how, like, their oxygen levels were going down. So it was like crazy how they had to figure out all these different things. It was remarkable. But number 2 here is the atmospheric. So 1 is oxygen level. 2 is atmospheric transparency. That's just a big word. Okay? What does that mean? The atmospheric transparency is how thick the atmosphere is.
Okay.
Wow, see, it really wasn't that deep. Transparent, I can see through this. I cannot see through this. Okay? It just means to be transparent. Like, as a disciples, when you're saying you're transparent, you're open.
Yeah. Oh, well.
You with me?
There it is.
Okay? If you got your walls up, you're transparent. You ain't open. With me here? Okay, now, what's cool about it? Sometimes it's important to kind of dump stuff down to kind of make it clear. This stuff is really not that deep when you really break it down. Atmospheric transparency. What does that mean? Well, what this is that if the atmosphere around the Earth, right, were less transparent, then not enough solar radiation would reach the Earth's surface. You understand what I'm saying? Solar, sun, radiation coming in. Right. If it was not transparent, we wouldn't get enough sunlight from the sun to be able to sustain life. Wow. Right? If it was more transparent, right, thinner, right, we'd get so much. Dry up. That's it. That's it. We're done. Right? We'd have too much solar radiation. So what's crazy is that, and then, so like this whole, like, okay, I have to write it out. It's pretty simple, right? Too much, you don't get enough sun. Too little, too little, you don't get enough sun. Too much transparency, right? Everything comes through, and you're a crispy chicken. Right? Now, what's crazy is that this is just the transparency of the atmosphere. This isn't even talking about what the atmosphere is made up of. If the atmosphere, what the atmosphere is made up, it's made up of nitrogen, oxygen, carbon dioxide. All these different things are constants in and of themselves. If this stuff changed, we wouldn't be able to live or breathe and do anything. But it's just an accident. Number 3, this is really cool. Do you know that the moon and the Earth, there's a gravitational pull? Yeah. Like, for example, the Earth has a gravitational pull. So like when astronauts have to, like, they blast up, right? They get past the atmosphere, right? And then they're in space. Right? Right? Well, they have to make sure they come in at the right angle to get back in. Because if they come in at the wrong angle, they burn out. Oh, yes. This stuff is some deep stuff.
Wow.
Astronomy is really cool, but even this whole space travel stuff, honestly, the more, I read so many daggone quotes in here about this Apollo 13 thing, that all these astronauts are like believing God. They're like, this is ridiculous.
Wow.
Really, it's actually ridiculous.
Awesome.
But what ends up happening is that when the spaceship comes and gets ready to go back into Earth, the gravitational pull of the Earth is so strong, they start coming down quick, like 12,500 miles an hour. Wow. That's 7 miles per second. Can you imagine that? 7 miles per second. That's how strong that gravitational attraction is. Right? And in the same way, there's an attraction between the moon and the Earth. Like, what's really cool about this is that if the interaction were greater than it currently is, then the tidal effects in oceans and all that stuff would be too severe.
What?
You have times tsunamis and worse than tsunamis like every day.
Dang.
That's what would be going on, right? Also, it would not only affect the oceans, it would affect the atmosphere, which means we wouldn't be able to live. And then it would also affect the rotational period going around too, right? If it was less, if this gravitational attraction was less, then there would be climatic instability. So like the summer and winter would be like severe. It would be like changing. It would be severe. You would be able to live again, right? In either case, life on Earth would be impossible.
Wow.
These are just a couple different concepts. What's really crazy, another one is carbon dioxide. What is that?
Carbon dioxide.
Carbon dioxide.
High blood pressure.
Now, in the spaceship, that's what was going on. Like, literally, these guys in the Apollo 13 mission, what was going on is that they were literally, because the oxygen tanks got shut down and all this stuff, they were being killed by their, literally, they were dying by their own exhaling of carbon dioxide. Because the oxygen wasn't circulating, so they were literally killing themselves. Every breath they took, when they exhaled, that's carbon dioxide. When people try to kill themselves by going in the garage and putting the car on. Well, that's carbon monoxide, but you got my point. Right? But just to think about it, whoa, this is intense, guys. Come on. Right? What's crazy about this is that if the CO2 level was higher than it was right now, this whole greenhouse effect would happen where we'd all burn.
Oh my God.
Okay? If it was lower, we wouldn't be able to have photosynthesis. You guys have photosynthesis, right?
Yeah.
Right? Which means that we would suffocate.
Wow.
Okay? This is ridiculous. All this stuff. Okay. This is just 5 of the 122.
What?
But of course this is all accident. Right? Okay. What's crazy about this too, as I said, can you imagine how strong? I mean, it had to be perfect. It was serious. I was reading about this, 25,000 miles an hour for this thing. That's how strong the gravitational pull was. Literally, God just put the moon at the perfect spot so that we could be able to live and do all this stuff.
Yeah.
I won't even go into the fact that even the alignment of the planets are cool, because if Jupiter wasn't there, and the rings around Jupiter weren't there, we'd be basically bombarded by all this space debris that would kill us. But literally, Jupiter, with all those different rings, stops space debris from hitting Earth.
That's gangster, bro.
So thanks, Jupiter.
Thank you, Jupiter. I thought we were supposed to go to the stupid.
But here's the other thing.
Jupiter.
Now, remember I talked about gravity, right, guys? Yeah. Not only between the moon and the Earth, but obviously this gravity here on Earth, right? Remember we talked about the whole concept of the Big Bang? Boom, right? When that happened, gravity also came into place. Come on. Right? And gravity, let me explain to you. This is how fine-tuning gravity has to be. Otherwise, if it was too much, no planets would have been formed. And if it was too little, the universe, when the boom happened, it would have collapsed back in on itself.
Dang.
This is how precise gravity had to be.
Need more water, bro?
Can't you just put a 10 to the negative something?
Come on!
37 zeros and 1.
Alright.
I would just write
If the
1
gravitational
to
force, right?
Like, how many zeros?
Right? Was altered by 0 to that percent.
Oh, man.
Right? Our sun would not exist.
Oh.
And neither would we. That's how precise gravity has to be. For us.
37.
37 zeros. Ridiculous. That's I want to help us understand something. If gravity changes by this percent, not 0.1%, not 0.0000, by 37 zeros and a 1. Places. If it changes by this percentage, we die. Is that ridiculous?
Is that even
That's
a
how
percentage?
precise the world is. That's how precise gravity is.
It's like so small.
So you see, for us guys, you know, there's so much fine tuning. Like I can give you 10 more here. It's ridiculous. If the centrifugal force of planetary movements did not precisely balance the gravitational forces, nothing would be held in orbit around the sun. If the universe had expanded at a rate 1/1,000,000th more slowly than it did, expansion would have stopped and the universe would have collapsed in on itself. If it expanded faster, no galaxies would have formed. Any of the laws of physics can be described as a function of velocity of light, which is 300